Right now, you're roughly 16 hours away from your brain beginning to malfunction, not figuratively, chemically. Every human being on Earth operates on the same countdown. Sleep resets it. If you do not reset it, the sequence that follows is identical for every person, in every study ever conducted. By hour 24, your brain will function as though you are legally drunk. By hour 48, it will begin generating images of things that are not there. By hour 72, you will believe them completely. In December 1963, a 17-year-old named Randy Gardner decided to stop sleeping. He was a high school junior in San Diego, trying to win a spot at the Greater San Diego Science Fair. His project was simple: stay awake longer than anyone ever had and write down what happened. The previous record was 260 hours, set by a radio DJ in Honolulu. Gardner and two classmates decided to beat it. No drugs, no stimulants, just willpower and a notebook. He woke up at 6 a.m. on December 28th. He would not sleep again for 264 hours. What makes Gardner's attempt different from every sleepless stunt before or since is who showed up to watch. William Dement, one of the founders of modern sleep research, flew to San Diego from Stanford the moment he heard about it. A Navy physician named John J. Ross monitored Gardner's vital signs around the clock. Between Dement's observations and Ross's medical notes, Gardner's 11 days became the most detailed record of progressive sleep deprivation in scientific history. And what they documented was not a story of willpower. It was a story of a brain systematically taking itself apart. The first 16 hours were unremarkable. They always are. This is where you are right now, somewhere in the middle of your normal waking day. No impairment, no measurable decline. Your brain is doing what it was built to do. Hour 17 is where it starts. In 1997, sleep researchers Drew Dawson and Catherine Reed at the University of South Australia ran an experiment that would reshape safety policy worldwide. They measured cognitive performance in 39 people under two conditions: extended wakefulness and measured doses of alcohol. After 17 hours without sleep, participants performed on reaction time tests as poorly as people with a blood alcohol concentration of 0.05%. Response speeds dropped by as much as 50%. After 24 hours awake, they matched a blood alcohol level of 0.10%. In the United States, you are legally too drunk to drive at 0.08%. Think about what that means. A person who has been awake since yesterday morning is, by every measure that matters, impaired beyond the legal limit for operating a car. They do not feel drunk. They feel tired. And that gap between what they feel and how they are actually performing is where people die. Most fatal drowsy driving crashes happen in this window, between hour 17 and hour 24. Randy Gardner hit hour 24 and was still standing. He was irritable, unfocused, and his short-term memory was already failing, but he was awake. Then came hour 36. Somewhere around hour 25, the brain does something it has never been asked to do. It starts shutting itself down in pieces. Not all at once, not neatly, in fragments. These are called microsleeps. Your brain forces itself offline for anywhere from a fraction of a second to 15 seconds at a time. Your eyes can stay open. You can be sitting upright. You can be behind the wheel of a car moving at 70 miles per hour. But for those seconds, your brain is not processing anything. No visual input, no sound, no awareness. You lose pieces of your life with no memory of them. You do not know they happened. Nobody around you can reliably tell. In Gardner's case, by hour 36, his speech was slurring. He could no longer reliably identify objects placed in front of him. He mistook a street sign for a person. His brain was starting to fill gaps in its failing attention with things it made up. By hour 48, the hallucinations began. They started small. Peripheral shadows that moved when nothing was there. Pattern recognition going haywire, the brain finding faces in random visual noise, figures in wallpaper, shapes shifting at the edges of his vision. These are not random glitches. This is what happens when the brain's visual processing centers, starved of their nightly maintenance cycle, begin misfiring. The system that normally separates real signals from noise loses its calibration. Everything starts to look like something. Gardner's short-term memory was collapsing. He would start a sentence and forget what he was saying before he reached the end of it. On day 4, he was asked to subtract 7 from 100 repeatedly. He stopped at 65. When asked why, he said he had forgotten what he was doing. His sense of identity was blurring. At one point, he became convinced he was Paul Lowe, a running back for the San Diego Chargers. He weighed 120 pounds. Now something worse. Between hours 49 and 72, the boundary between dreaming and waking dissolves. This is the phase where the brain, unable to enter normal sleep, begins dreaming while you are awake. Dream imagery overlays reality. You are standing in a room that is real, but parts of what you see are being generated by the same circuits that produce dreams. You cannot tell which parts are which. Gardner became paranoid. By day 10, he became fixated on a radio show host, convinced the host was deliberately trying to make him look foolish. He was hearing things in broadcasts that were not there. His speech had lost its intonation. His face was expressionless. Ross noted that his cognitive function was almost indistinguishable from someone in the early stages of psychosis. On January 8, 1964, 264 hours after he last slept, Gardner held a press conference. He appeared coherent. He answered questions. He slept for 14 hours and 46 minutes and woke up apparently normal. And for decades, that press conference was the only part of the story anyone remembered. The takeaway became folklore. A kid stayed up for 11 days and he was fine. He was not fine. In 2017, Gardner told interviewers he had been suffering from severe insomnia since around 2007, decades after the experiment. He said he believed the 11 days of deprivation had permanently damaged his ability to sleep. Guinness World Records stopped recognizing sleep deprivation attempts in 1997 because the evidence of long-term harm became impossible to ignore. But here's the part that changes everything about the timeline you just heard. The obvious conclusion, the one your brain has already assembled, is that sleep deprivation makes you go crazy. Stay up too long and your brain starts malfunctioning, like an engine running without oil. Eventually it overheats, and when you finally rest, it cools back down. But that is not what the science actually shows. Your brain is not breaking down because it is tired. It is breaking down because it is poisoning itself. In 2012, a neuroscientist named Macon Nedergaard at the University of Rochester discovered a system inside the brain that no one had known existed. She called it the glymphatic system. During waking hours, your brain produces waste, metabolic byproducts from the constant firing of 86 billion neurons. Damaged proteins, broken down neurotransmitters, cellular debris, all of it accumulates while you are awake, and during the day, almost none of it gets cleaned up. When you fall into deep sleep, something changes. The spaces between your brain cells expand by roughly 60%. Cerebrospinal fluid, the clear liquid that bathes your brain, rushes through these widened channels like a pressure washer. It picks up the accumulated waste and flushes it out through your lymphatic system. The entire operation depends on you being asleep. The glymphatic system is roughly 90% more active during sleep than during waking. When you are awake, the cleaning system is essentially offline. Among the waste products it clears is beta amyloid. That protein is one of the primary components of the plaques found in the brains of Alzheimer's patients. Every hour you spend awake, beta amyloid accumulates. Every hour you spend asleep, it gets flushed away. When you do not sleep, it stays. It builds. And the longer it builds, the more it interferes with the very neurons that are trying to keep you conscious and functional. The 72-hour timeline that Randy Gardner lived through is not a story about willpower running out. It is a story about a brain drowning in its own waste. The hallucinations, the paranoia, the loss of identity, the psychotic episodes, these are not symptoms of tiredness. They are symptoms of toxicity. The brain is poisoning itself because the only system that can clean it is locked behind a gate that only sleep can open. And here's the proof that the damage is not just temporary. There is a disease that does what Gardner did to himself voluntarily, except it never stops. It is called fatal familial insomnia. It is caused by a mutation in a single gene, the PRNP gene, which produces misfolded prion proteins that destroy the thalamus, the part of your brain that controls sleep. Patients with this mutation gradually lose the ability to sleep at all. First, they struggle with insomnia. Then they stop sleeping entirely, then the hallucinations come, then the psychosis, then the dementia, then they die. Average survival from symptom onset is 18 months. There is no treatment. There is no cure. Every single person diagnosed with fatal familial insomnia has died. The progression mirrors sleep deprivation almost exactly, played out on a longer timeline. The same cognitive disintegration, the same hallucinations, the same paranoid ideation, the same collapse of the boundary between self and the outside world. Fatal familial insomnia is the closest real-world evidence that total sleep deprivation is lethal. You do not die from being tired. You die because your brain can no longer clean itself, and the accumulation of toxic proteins destroys it from the inside out. Modern culture treats sleep as optional. It is the first thing you sacrifice for a deadline, for a Netflix season, for one more hour of scrolling. Hustle culture celebrates sleeplessness as a badge of discipline. Entire Asia industries are built on the assumption that sleep is time wasted, hours you could be productive, hours you could be earning. The research says something different. Sleep is not rest. It is maintenance. It is the only window your brain has to clean itself. There is no substitute. Caffeine does not trigger glymphatic clearance. Napping cannot replace deep sleep's full cleaning cycle. There is no drug, no supplement, no biohack that replicates what happens when cerebrospinal fluid floods the spaces between your neurons and washes away the debris of a day spent thinking. Every hour you borrow from sleep is paid in a currency your body cannot print more of. The 72-hour timeline is not a curiosity. It is a warning. The hallucinations, the paranoia, the cognitive collapse, they are your brain telling you, in the only language it has left, that it is running out of time to save itself. You are 16 hours from the edge right now. The only thing between you and what Randy Gardner saw is tonight.